Subject rate is rational expression. So if you remember back when we did functions, remember when we did f of x over g of x, which was division, right? And I said that when you've got something like this, all you're going to do is write like whatever f, now I'm just making up these numbers, so that you would write whatever f of x is over whatever g of x was, right? And I told you not to go any further, right? Just leave it. The reason is because to simplify these, it's kind of complicated. It's a lot of words. And that's what we're going to look at today. So this is a rational expression. And a rational expression is just the ratio of two polynomials. So polynomials are the kinds of equations we've been messing with, right, for really all of the years so far. So a rational expression is just when you have one of those equations or expressions over another. It just makes it more complicated because you have a fraction with variables, right? So, so this is like a technical math definition of a rational expression. This little phrase right here, so it says a rational expression is p of x over q of x, okay? And if this q of x cannot equal 0, you'll see that a lot, and that just means that this expression on the bottom cannot be 0. Because what happens if a fraction has a 0 on the bottom? What's that? The answer is not 0, but it's negative, undefined, right? So you'll always see like this kind of additional note on these. And this has to do with the domain. Okay, we're not going to get into this too far in this class, but in pre-cal, when you look at these, there'll be a lot of talk about the domain. Okay, so right now, just know that this just means that you can't have any values of x that would make that bottom value 0, because you can't have a fraction with the 0 on the bottom. Okay, so first thing we're going to do is simplify these. If we look at this, it says a rational expression is in simplest form when its numerator and denominator are polynomials that have no common divisors, right? Or no common factors. So the first thing we're going to do is practice getting rational expressions to its simplest form. And that is really going to be just factoring and canceling out common factors. Okay? Okay. So first thing we're going to do is talk about reducing rational expressions. So the first step is factoring. So that's one reason that why we jumped to this chapter right now. Is because we just factored in chapter 5, chapter 4 and 5. So while factoring expression in brains, we're going to use it. So somebody, what ways do we have to factor? Like shout out one of your favorite ways to factor. GCF. What else? AC method. AC method, what else? Subtraction, difference of squares, that's my favorite. And then, to be honest, I'm not sure what I had planned on in this last blank, but it could be any of the new ones that we learned last chapter also, like sum of cubes, remember, or we did grouping, and we did substitution. But honestly, we're going to use more of the quadratic ones that we did. So really, in today's lesson, it's going to be more GCF, AC method, major function groups. Okay? So first of all, you're going to always try to factor however you can. And then you're going to cancel out matching factors from the top and bottom. Okay? So cancel out anything that matches, but you have to be really careful, and this is the most important thing that you can take from today, is that you don't want to break up what I call a factor family. Okay? The family is going to be anything with an addition or subtraction sign to it. Okay? Such as like x plus 3, that's a little family. 2x minus 7. Okay? So these factors can only cancel if you can cancel out the entire parentheses, right? Top and bottom. Okay? And you'll see what I mean about it, more than time. Okay, but just remember, if it's got an addition or subtraction, it's part of the family, and the whole thing has to be canceled, not just we don't break, we're not family, we're not home records here. We're not going to break up the family. Okay? Okay. So let's look at this one. So the first thing we'll do is, again, back to the top, back to the bottom. How can we back to the top? I got 2x. And we're left with 2x minus 3. Right, do that. Now, can we do anything on the bottom? No, 2x is 2x, right? But now we have 2x on the top. This 2x is not part of the family because this one is not being added or subtracted. It's actually what I call single. And we have a 2x down here. So now those cancel, and we're left with just 2x minus 3. Well, because this 2x is part of this family, okay? So the only way this 2x could be canceled is if the entire 2x minus 3, okay? All right? Now, if there's no addition or subtraction, like this one, then it's really just a problem like we did for homework last time, right? So on this type of thing, you want to reduce it just by looking at every piece of it, right? So 27 over 3 can reduce to 9, right? X squared over x to the third reduces to what? What? X on the bottom, right? And then y to the third over y squared reduces to y on the top. So there were no factor families in this one. So we were able to just cancel separate or singles. Okay? All right. Now let's look at this one. So x minus 3 over x squared minus 9. So can we do anything with x minus 3? No. And I really do recommend, especially at first when you're trying to get adjusted to like what's a family and what's not, if it's just a little fact like that, put parentheses around. And then you just have to know you cannot break up the parentheses. Okay? Now, x squared minus 9, how could that happen? Well, it's difference is squared, right? So x squared is x squared, right? And 9 is 3 squared, right? Minus 3 plus 3. So now, if we find a factor entirely matching, we can cancel those out. So this x minus 3 can cancel with that x minus 3. And we're left with just a 1 on top. Okay? When everything cancels, we still have a 1 on top over x plus 3. Okay? Alright, let's try the next one. So, 2x squared plus x minus 10. How can we factor that? What method? We can't take out GCF, right? There's no AC method, right? So let's review AC a little bit. So the first step in AC method is A times C, right? So 2 times negative 10 is negative 20. So what multiplies to negative 20 adds to 1. What we got? What multiplies to negative 1? Right, negative 4, 5. I'm going to do 5 negative 4. Okay? And then what do we do?
Oh, use your x, 1, 4, 5, and not
Right, so we rewrite it, right? So I'm going to do 2x squared plus 5x minus 4x minus 10. Don't you know?
yeah.
Okay? And then we split down the middle, right? Well, can we take out over here from 2x squared plus 5x? We have x, and we get 2x plus 5. Remember on this one, if this is a negative, we bring down that sign. So we take out a negative. Now what can we take out between 4 and 10? A 2, right? So we take out, and we're taking out a negative 2. So negative 4x divided by negative 2 gives us a positive 2x. Negative 10 divided by negative 2 gives us a positive 5. So our factors up here become what? X minus 2 and 2x. And then the bottom, we can use magic question, right? So we'll multiply to negative 10, adds to positive 3. Multiply to negative 10 adds to positive 3 would be what? 5 and negative 2. So we get x plus 5 and x minus 2. So we back to the top, back to the bottom. And now what can we cancel? So now we have to cancel complete families. X minus 2 and x minus 2 and nothing else, right? So our answer is whatever we have left. So we have 2x plus 5 and x plus 5. Now, can we cancel out those 5s? No, right? Okay, so again, if it's part of a family where it is being added or subtracted as part of a factor, you can't break those up. So this is a final answer. Okay? The biggest mistake you can make is to try to cancel out those 5s or those x's. Okay? You cannot do that when it being added or subtracted or something else. Okay? Alright? Now let's try another one. And sometimes we need to use a little trick. Factor x squared minus 5x plus 6. What method? Next question. So what multiplies to 6 adds to negative 5? 6. Negative 3 minus 6. Now, what about the bottom? 4 minus x squared is what? X squared? Difference is squared, right? So again, though, you have to look at the order. So this is 4 minus x squared. So the square root of 4 is 2. Square root of x is x. So this becomes 2 minus x, 2 plus x. Okay? The factors look a little bit different because the actual equation looks a little bit different than what we used to, right? Okay, so now we want to cancel. X minus 2 is not the same as 2 minus x. Does everybody see that? Because here the x is positive, down here the x is negative, up here the 2 is negative, down here the 2 is positive. Alright? So they're close, but actually complete opposites. Okay? But we really want to cancel them out. So what can we do to 2 minus x to change the sign of everything inside? Negative. Multiplied by negative 1. I don't want, and that's what it's going to look like. But we don't want to add anything into this expression. So what we're actually going to do is take out negative 1. All right, we're going to take out a GCF of negative 1. So it stays in the problem that we're able to write this. If we take out a GCF of negative 1, then the 2 becomes a negative 2, and the negative x becomes positive. Okay, so anytime you see, it's only going to happen on subtraction, right? Because if it's addition, order doesn't matter, right? If we had a 2 plus x and an x plus 2, those are the same, right? They're just rearranged. But these, the signs are different. So anytime you hit the signs completely different, just take out a negative 1 and you can change all the signs. You just take out one factor. Yeah. Because if you took out the other one, then you're back where you started. Okay? So you take it out of one. And now that allows those to cancel. Okay? And it's really all the cancel, right? So x minus 3 doesn't cancel with anything else, 2 plus x doesn't either. So our final answer here is x minus 3 over negative 1, 2 plus x. Okay? And now, so you can leave it like this. You'll get full credit if you leave it like this. But on a fraction, if you have a negative on one piece and not the other, right, it really just means the whole fraction is negative. So like the book would write this, it would just bring the negative out in front. And so that's kind of like the most proper. Okay, questions about that? Okay. Yeah, that's one for this page. What can we do with the to the top? 5x squared minus 15x. Do you see that, Pam? What's there to see? Is it you said that? Right, so we can take out 5x. And we're left with x minus 3. What about the bottom? 3x squared. And we're left with x minus 3. So what can we cancel? Others, what can we do? Right, x 3. Anything else? Natalie? Yes, that's right. So this top one can cancel out completely with one of these, right? Everybody see that? So then we look at what's left. We have a 5 left on top, and below we have 3x. Okay. Now, one way that I want to encourage, if you didn't see those x's to cancel, then you could have brought it down at first and said, okay, I've got this. Okay, but again, just like you always want to look at your fractions, see if they can reduce, you always want to look at your radicals, see if they can reduce. You always want to look at this and see, oh, could I have done more? And in this case, yeah, we could have reduced that. Okay? Okay, I want everybody to get a whiteboard and practice this. Okay, so now we're going to multiply. So actually, if you think about multiplying fractions, let's say, you don't have to write this down. Let's say I have 2 over 7 times 21 over 6. How do I multiply this? You don't cross multiply, but you can kind of cross cancel, is what I kind of call it. So how can we cross cancel this? Right, the 2 could be a 1, right? So the 6 could become a 3. And what else? 7 is a 1, 21 is a 3. And then if you cancel everything you can, then you just multiply across, right? So 1 times 3 is 3. 1 times 3 is 3. So our answer is 1. Right? Okay, so same thing with rational expressions. So what we're going to do with rational expression multiplying is we're going to factor. So we factor everything, all 4 pieces if we can. And then we can cancel factors, anything from the top can cancel with anything from the bottom. Either right on top of each other or diagonally, right? And then cancel diagonally. And then you just multiply everything that's left straight across. Okay? So, I told you can use factoring in your life, right? Right in our life. That's not life, right? Okay, so how do we factor x squared plus x minus 1? Well, multiplies to negative 12, adds to 1. 1/3. 4 and negative 3. X plus 4, x minus 3. What can we do with x squared minus 9? X plus 3, x minus 3. What about 2x plus 6? What was that? It's coming. question, what can we do with 2x plus 6? Audrey, what can we do with 2x plus 6?
You can't cross out the X.
No.
Take out the 2. Take out the 2. And mark X.
All right, go 5. Okay, so we can take out 2 and we get 2 times x plus 3. We can't do anything with x minus 5, but it's a family, right? Now, what can we cancel? Christina, what can we cancel? X plus 3. And line, what else can we cancel? X minus 3. Anything else? No. So now we gather what we've got left. So up numerator we have 2x plus 4. On the bottom we have an x minus 5.
How are we able to do the addition? Like, how are we able to cross out the negative 3?
Because I had negative positive 3 here. Oh, I did. Yeah. So they can be right on top of each other or they can be diagonal. Right. So you could distribute this back in, but I'd rather you didn't. Okay? Because this way, if you keep it factored like this, then it's obvious that nothing else can cancel. Okay? So if it's, some people might like automatically like say 2x plus 8, and I'll count off of that, but it's better to leave it simplified. Okay? All right, let's do the next one. Okay, so now this one is HB method again, but it's the same one we already did. Okay, so it factors to 2x plus 5 and 2x, x minus 2. So we already did that. Yeah, we already did that last one. Okay. All right, what can we do with x squared minus 9x plus 14? Well, multiply 14 adds negative 9. Okay? Negative 2 makes 7. Can we do anything with 5? No. What about 4x squared minus 25? Difference of squares. What would it be? There you go. 2x minus 5. 2x plus 5. So Caitlin, what can we cross out?
X minus 2.
X minus 2. Claire? 2x plus 5. This is kind of fun. You can like cross out things. Okay. Now, again, I don't see anything else, so I'm going to collect what we have left. We have a 5 up top, and we have an x minus 7, and a 2x minus 5. And then again, take a look at it. Really can't see anything else if we can. That's easy. Okay.
Wait, what did you do? The first, the 2x plus 5 on the top left.
Oh, this we had factored on the previous notes. We done AC method.
Okay.
And I had to use a simple. All right, go quiet. Okay, now this next one's kind of crazy. The next one's kind of overdone a little bit. But I wanted to show you how in this one, there's no factor families, right? Because there's nothing addition or subtraction, okay? So they're all being multiplied. So we could actually write this all on like one line over the next one. You know, it's really just multiplication. So we can really cancel anything on top with anything on the bottom anywhere, okay? So, somebody want to tell me something I can cancel? Ed.
You can cancel for like current 2 and 12. You can cancel out the 2 and one of the A's. For like the bottom one.
So, well, one at a time. So the 2 and the 12, what happens to the 12? You go to 6.
And then the A, the one like over that one becomes a 1, and then the other one becomes a 1.
Okay. Anybody else? Claire? C's both are 1s, right? You see the first thing. Is the Y. The Y. 1 Y and 1 Y. Right? Now, Okay, what happened? And the 9 cancels. What else? Somebody else? Huh? Like, 4. Okay, so let's stop there and see what we got. So up top we have A, B to the 4th, 3, and Z. Well, hang on. So we decided to stop. Just a second. And then on the bottom we have x squared, z to the 3rd, 6. Okay. So yeah. So we've stopped. We've looked at it again, and now again we can see we're not done yet, right? So the z. What happens with the z? The first one goes away. What happens down here? It comes to 2. Anything else you can see that we could cancel or simplify? 3 and 6, right? So 3 goes into 6 twice. So now our final answer is ab to the 4th over 2x squared z squared. And now we can look at that and we can see that we've got everything, right? Nothing else. Okay. All right. Now I want you guys to try this. Now, hey, Mary. Hi, everybody. Okay. Actually, well, Mimi asked for it, so hopefully Mimi's gonna watch it. Okay. So if you factor out everything, again, you can only cancel out 1 to 1. So we only have 1 x plus 4 up here. So that only is good to cancel 1 x plus 4 on the bottom. Okay? And then we have an x minus 4, an x minus 4. That's it. So looking at the top we have 2 and an x plus 1. On the bottom we have an x plus 4 and an x plus 4. So you can leave it like this. You don't want to foil it back together, okay? But one way you could write it is a book would write it is write this and then x plus 4 squared. That's you can do that. But you don't want to foil it back together because then you have to think to make sure you're finished. You know, you have to like factor it in. So, okay. What are your questions about it? All right. So that's multiplying. Okay, so let's multiply. So now we're going to move to dividing. Okay? Now let's talk about dividing fractions. So if we had okay, if I were to divide those fractions, what would I do? And okay, so the 2/5 would stay, right? And then what would I do? So I change this to multiplication, right? And then I flip this. Now what can I do? You don't cross multiply, you cross cancel. So then what can I do here? 5 and 3, and then I would multiply cross, right? So I would end up with 6 over 3 over 2. If I agree with that? Okay? So we're going to do the same process with dividing rational expressions. So we're going to factor it just like we did. But then we're going to flip the second fraction, change it to multiplication, and then we're going to do just what we've been doing with multiplication. Cross cancel, right? Anything on the top, anything on the bottom. Now, you have to be really careful because where people miss points on this is thinking you're flipping it in your head or you're forgetting to flip it, okay? So you don't have to rewrite the entire problem, but I would recommend rewriting the factors on the right levels, okay? So again, this is the same AC method that we did earlier, so we're just going to bring that down. 2x plus 5 over x minus 2. Okay? So to factor this one, what multiplies a negative 10x3?
Or 5.
5 and negative 6, yeah. So we got x plus 5, x minus 2. Now, I'm going to change the division to multiplication. Okay? And then, I'm going to take what's on the bottom here and put it on the top. So what can I do with 5x plus 25? But I put that on the top, so I'm flipping that second fraction. Okay? I'm going to take what's on the top of the second fraction and put it on the bottom. So what can I do with 6x squared plus 15x? We got 3, and what else? They got an x, right? So they got a 3 and an x, and I'm left with 2x plus 5. So now I have a multiplication problem, right? So what can I cancel? Result? 2x plus 1. 2x plus 5. Okay. X plus 1. X plus 5. X minus 2. Anything else? So now I look at what I have left. I have a 5 on top and a 3x. Okay? Now I took out, so this one came down. Right? Okay, another one, almost done. Okay? Very good. On the table. What's that? Okay, so now on this one, so the first part stays the same, right? We can do anything with 2x to the fifth. What can we do with x squared minus 2x? Take out an x, right? And we're left with x minus 2. We change the multiplication, the division to multiplication. And we flip it, right? So 4 minus x squared is going to become what? 2 minus x, 2 plus x. We'll leave it at that for now. X to the third comes down. Now, what can we get? So what else do we need to do? I'm not doing no. Again, that's what we're talking about. That's not the same thing because x minus 2x plus 2 would be x squared minus 4. And we don't have that. So you have to start out like this. Now, we have a trick, right, to make those two match. Now, right, so take out a -1, and now they match. But you can't just jump to this, okay, because you need that -1 in the problem, okay? So now, x minus 2 cancels with x minus 2. What else? Caroline? And 2 cancels, right? Very good. What else? What about all the single x's? Right, so this can go to x squared, and this goes away. But now, what about this x? Well, it'll stay for now. So let's go ahead and gather what we have. We have x squared up top. We have a -1. I'm going to make that negative outside. And then we have a 2 plus x. And then we have a 3x on the bottom, right? This 3 and that x. So now, can we simplify this any further? the x's, right? So even though like we had x to the fifth up top, we had one x over here and three x's here, we still had a total of four x's on the bottom that could cancel out with the five x's up top. So now this goes away, that becomes 1. The final answer is negative x 2 plus x over 4. Okay, am I good? All right, one more, all right?
No thanks.
Sorry, not an option.
It's really hard to tell you this.
But actually, it's not hard. It's actually on your feet. No, it's read it.
2x plus 14 divided by 9 divided by x squared minus 14.
Right. Okay, that's one way to read it. Another way to think about it is 2x plus 14 over 9 divided by x squared minus 49 over x squared. Okay, so this is really just a different way of writing what we can do. So this really simple, or can be written like this: 14 over 9 divided by x squared minus 49 over x squared. Does that make sense? Yes, that's what we're going to do. And then, so now what you guys do this one up. So change it to multiplication. And, okay, so, wait, so the fact is becomes 2x plus 7, right, over 9. Change this to multiplication, right? And now the 18 goes on top. And down here it becomes x minus 7, x plus 7. Okay? Now, you cancel the x plus 7, cancel the x plus 7. The 18 goes into, the 9 goes into 18 twice. So now, on top, all we have left is a 4. On the bottom, we have an x minus 7. Okay? You really, just trust me on this, on division, you've got to write it flipped. Okay? Because you can't try to keep your head and keep track of what's up top, what's on bottom. Okay?
Go get the paper.